Hello again to another Agricolor reaction. Today we'll be watching Earth's 7 lowest points by continent, 7 lows, plus lowest underwater and ice, and plus lowest by countries from Geography Wiz. I believe I never seen anything from Geography Wiz, and let's just learn something new. Let's just see what kind of what are the lowest in the world.
The previous Geography Viz video covered what are known as the 7 summits. Paralleling that, this video looks at Earth's lowest elevation points by continent. As a bonus, we'll also look at other low points, such as those under water and ice, and we'll look at what countries of the world have areas below sea level, and map all the major depressions. All continents have low points below sea level. And we'll start with the least deep continental low, which is for Australia, and Lake Eyre, at 15 meters,
Lake Eyre?
49 feet below sea level. It is sometimes a huge, shallow lake, but most of the time, it's mostly a salty playa surface.
Wow.
This large depression has been shaped by episodes of deflation or large-scale wind erosion, which you can see in the wind-scoured surrounding landscape. However,
like Erie.
seismic evidence suggests that formation is primarily
United States,
due to long wavelength
Canada
tectonic subsidence that is associated with a sinking subduction remnant. Check the refs in the video description to get all the details for that. Next is the Caspian Sea, shoreline at 28 meters or 92 feet below sea level.
That's a lot.
The Caspian Sea is Earth's largest inland body of water, a feature easily visible from space. The formation of this basin is associated with tectonic convergence and the closure of an ancient ocean basin tens of millions of years ago. The Caspian seafloor thus comprises oceanic basalt as opposed to continental granites. In addition to the largest water body, the Caspian Depression also contains the largest land surface area below sea level and the world's largest city below sea level, Baku, population exceeding 2.6 million people.
That's a lot. That's a big city, huh?
On a wedge of exposed bedrock along the shoreline of aptly named Deep Lake at 51 meters or 167 feet below sea level. This depression was formed by locally concentrated glacial erosion at a site of weaker or more fractured bedrock. With ice sheet retreat and isostatic rebound, glacially sculpted bedrock slopes and depressions become isolated from the ocean while remaining below sea level, such as here and here. With its remoteness and harsh polar climate, this is the least accessible destination for would-be low-pointing tourists.
It's actually a lake, huh? I thought that would be like a
is North America.
Cold
Death
like that.
Valley,
But there's
at
no
86
lake.
meters or 282 feet below sea level.
Death Valley is below sea
Is
level?
a basin range physiographic region of the western U.S., where extensional forces of the crust have caused extensive regional faulting, forming a series of parallel mountain ranges and valley basins. Death Valley is a particularly deep one, situated between two huge, rotated block mountains. The deepest valley bottom location is the salty playa surface of the Badwater Basin.
We drove through Death Valley 4 years ago, and it's an interesting place, but we didn't have enough time to actually kind of like see a lot. We stopped by the sand dunes, then the Star Wars, the original trilogy of Star Wars was filmed on. And then we went to one of the viewing points, and I think that was viewing points on this side here, kind of on the right side of the Death Valley. But I can't remember now exactly. But it's kind of weird because I don't remember ever being mentioned that Death Valley is actually below sea level. Maybe it just skipped my mind some way.
Nearby Furnace Creek has the official world record for the hottest recorded temperature on Earth.
I'd love to see that salty one.
Then,
place.
South America. In the far south of Argentina, Laguna del Carbon, at 105 meters, or 344 feet below sea level. This is another basin formed by crustal extension, although at this site, extension is associated with its back arc tectonic setting. This results in the formation of a series of major half-gravens, which are valley features formed by a single primary normal fault. This depression contains many salt marshes and playa surfaces. In scientific literature, many interesting paleontology sites have been explored in this basin. Next is Africa, Lake Assad, at 155 meters, or 509 feet below sea level. This low point is in the Great Rift Valley that is tearing the African continent apart. Rift valleys are dramatic features of diverging continental crust. There is associated formation of a series of basin, valleys, and range mountains, as is visible in this background satellite imagery. And there's associated rift volcanics, which you can see in the recent basalt flows in the lower satellite imagery. The lake itself is reported to be a volcanic crater feature within this rift. A previous Geography Viz video has featured this hyper-arid, hypersaline lake as the greenest square kilometer of the African continent. Finally, we have Asia, with the Dead Sea of Jordan and Israel, at a staggering 437 meters, or 1,434 feet below sea level, in what is known as the Jordan Rift Valley.
Wait, so is the Caspian Sea
Note the raised
considered
shoreline
European?
is visible in the imagery from a half century or so of dropping water levels. Here's a map of regional tectonic boundaries for West Africa and easternmost Asia. The Lake Assal Rift is down here. From there, you can trace up the very active spreading margin of the Red Sea, up to what is primarily a transform margin, known as the Dead Sea Transform. So why do we have such a deep basin where plates are sliding horizontally past each other instead of diverging? Zooming into that transform margin at the Dead Sea, you can see the major fault boundary has a horizontal offset at this location. That offset results in the formation in what's called a pull-apart basin, which created this extraordinary deep depression. The sea's shoreline comprises the lowest dry land on Earth, and the sea is the deepest hypersaline lake in the world. It's a tourist destination, well known for many reasons, one being the high buoyancy you experience as a swimmer due to the high density of that hypersaline water. Let's plot transects for these 7 depressions to help show diversity in relief relating to their very interesting variety of formation processes. Air, with broad subsidence and wind sculpting, is one of gentle, low relief transecting the Australian Shield crest before slowly descending into coastal lowlands and a fairly distant coast. The Caspian Depression, in sharp contrast, has steep mountain slopes on some sides that are formed through tectonic convergence and collision. Deep Lake, Antarctica, is in low relief, glacially scoured hills and lowlands midway between the Southern Ocean and the Antarctic ice sheet. Death Valley, flat bottom basin, bounded by steep fault block mountain ranges. Laguna del Carbon is relatively gentle, low relief terrain, except for you have the exposed valley forming fault scarps. The Lake Assal Basin has evidence of receiving ocean inflow from the Gulf of Aden, but it is now protected from that by basalt buildups on its low rim side. Otherwise, it's surrounded by steep rift fault mountains. And then there's the deepest depression at the Dead Sea, with its very steep, prominent fault boundary before transecting into more gentle, mountainous terrain. All these depressions are hydrologically closed basins, and where they contain lakes, water levels can vary dramatically and be sensitive to changing hydrologic conditions. For example, the Dead Sea has lowered as much as about a meter per year in more recent decades, following climate change and a long history of inflow damming and diversion. Now there's considerable pressure and some effort to stop or at least slow its dramatic water loss. You can't get any lower than the Dead Sea surface unless you start going underwater. Lake Baikal occupies another major rift of our planet, and it has the deepest lake bottom on Earth, more than 1,000 meters below sea level, considerably deeper than what you can get going underwater in the still fairly deep Dead Sea. Even deeper, by a big step, is the ice scour depression below the massive Denman Glacier in Antarctica, reaching about 3,500 meters below sea level. And then there's an even bigger step down to the deepest point of the ocean, at over 11,000 meters deep, at Challenger Deep. Impressively, the Russians were able to bore down slightly deeper than that relative to sea level with the Kola super deep borehole in northwest Russia. I'll call these the 5 lows, the lowest points on Earth for dry land, for below lake water, under ice, the deepest ocean bottom, and what has been reached artificially by human drilling. Hard to get deeper than that. Average continental crust thickness is about 40,000 meters. The asthenosphere is down about 100,000 meters, and then you get into millions of meters for the Earth's core and center. But now we're getting a bit carried away. Here's a map to get back to our 7 lows, plus the other mentioned types of low points. I didn't quite want to stop here, as there
Cola
are
Super
over 30
Deep is
countries
in...
that have land areas below sea level.
Actually in
Let's
Europe,
briefly go through all the low points more than 100 meters below sea level. Argentina is first at 105 meters, which we already discussed, as it's also the lowest point for South America. Next is Ethiopia, 125 meters below sea level, with the Danakil Depression. This is situated in the African Triple Junction Zone, Rift Zone, quite close to the already discussed Lake Assal. This area is officially recognized by the International Union of Geological Sciences, as it's an extremely interesting geological heritage site because of its uniquely important tectonic setting. In addition to being a cradle of humanity, it's where the Lucy bones were found.
That's interesting.
It's also the hottest place on Earth in terms of year-round average temperature, and it contains the saltiest body of water on Earth. So, on so many levels,
I wonder if it's safe to go there and visit.
Then Kazakhstan, with a low point of 132 meters below sea level. I kind of like this one because its primary formation mechanism is totally different than all the other low points discussed. It occupies a karst trench, a feature formed as limestone and other soluble rocks dissolved into potholes and caves that eventually collapsed and merged, forming this deep valley. Next is Egypt, 133 meters below sea level, with the Kratera Depression, a huge area of low-lying salt pans, salt marshes, and sandy rocky desert. And more neat Earth surface processes associated with this basin formation. Here it's a combination of salt weathering and wind erosion. Precipitating salts break up the basin floor, and strong winds then blow away the produced sand particles. Then China, the Turpan Depression, with a low point 154 meters below sea level. Another fault-bounded depression with a harsh desert climate. This basin was traversed by the ancient Silk Road through what is, by many measures, the hottest and driest area in China. Then Lake Assal, Djibouti, 155 meters, already discussed as the lowest point for Africa. Next, Syria, 200 meters below sea level, at an unnamed location near the Sea of Galilee, a freshwater lake in Israel, the lowest freshwater lake on Earth and the second lowest lake in the world after the Dead Sea. This low point is also within the Jordan Rift Valley, north of the Dead Sea. The Dead Sea, at over double the low point depth of that of Syria, easily wins as the lowest low point on Earth. Final map showing land areas less than 0 meters of elevation, according to SRTM. That's the Shuttle Radar Topographic Mission digital elevation data. Right away, you see the massiveness of the Caspian Depression, which is also relatively far inland. The Australian main low point depression is also fairly inland. The most inland depression is the one we had mentioned in northwest China. Most remaining negative elevation lands are perhaps counterintuitively close to ocean coasts. Here are the deep Rift Valley basins of East Africa and West Asia. North Africa has a series of large depressions, largest being that quite deep one in Egypt. There have been proposals to divert water from the Mediterranean into that hyperarid depression, where it would continuously evaporate, and the inflow could generate hydropower. There are coastal locations you might expect to see in Europe,
That's an interesting
such as flood-prone areas at the top of the Adriatic, like Venice, especially up in the Netherlands. South America doesn't have a lot of low points, the most significant ones being in Argentina. Here is North America's Death Valley. Larger in aerial extent is the Salton Sea Depression, a pull-apart basin.
It's kind of interesting because, like I just mentioned, we did drive through the Dead Valley, and it's massive to me anyway. It was big to go there and see and drive because it took us probably like a day to just drive from one side of it to another side of it. Obviously, we did stop in the information centers and in a few places and things, but still, it was quite big, long, and things. So, looking at how on the map how small it is compared to Caspian Sea, or even to the Lake Erie in Australia, it's kind of interesting. How can you not wrap your head? I mean, I can't wrap my head around the sizes of some things.
Here's the well-known low-lying subsiding land along the Gulf of Mexico coast, especially at New Orleans. I chose to make this map using SRTM data because it has good global consistency and near global coverage. But I know that these other marked lowlands in Central Valley, California, around Florida, up the eastern US coast, and perhaps many other marked locations, are not actually below mean sea level. So it looks like the SRTM is biased slightly low at places, but they are all certainly low elevation areas of great flood concern. with ongoing climate change and sea level rise. See video text for methods and sources. And thanks for watching.
Oh, that's
like,
cool.
subscribe, watch more geography vids.
Yeah, so like I mentioned, I haven't mentioned, there is a depression in Poland as well. It's not very deep because it's only it was actually mentioned in his map, and it's like about 2 meters, so it's 6 feet. But it was just kind of something that we were taught in school in geography and things like that, and obviously we probably were taught about the other ones too, but obviously you kind of remember more of something that's relevant to you. But the thing about the sizes of the Caspian Sea on that map is just quite mind-blowing in my opinion. It's quite big compared to places that I've actually been in, the Dead Valley, and to me that was big. And I know that Death Valley probably doesn't compare to Grand Canyon that we've seen as well, and we've seen Grand Canyon only in the South Rim, and that was looking massive, but we still couldn't see, let's say, the end of it. So, and every now and then I see something, let's say there's a Marinara Valley in Mars, like bigger than the Grand Canyon. Like if you kind of put the that valley, I think it's a Marinara Valley, from Mars, would you put it on across the United States, or going from the east to the west? It's just sometimes the sizes is just something that I can't wrap my head around. And this, just thinking that there's something that is as deep as 500 meters below the sea level. The meters that's just a lot. That's a half a kilometer. That's a lot. That's very deep. And especially looking at that, excuse me, artificial thing that they made in Russia, 12 kilometers. I have to find something to watch about it, because it's kind of getting really interesting. So, what do you think about it? What do you think about the depressions around the world? Should I watch something more specific about it? I don't know. We'll see. Thank you very much for watching. I'll see you tomorrow. Bye.